Where's my water bottle? Okay, so we'll just start from the beginning. List at least 3 characteristics of the student's T distribution.
Bell-shaped and symmetrical.
Uh-huh.
So that's meaning like normal distribution.
Right.
The mean of 0, which I'm not totally sure how that works, but
Yeah,
we'll figure it out.
I don't really understand what it's asking, like the mean of 0
Yeah.
or saying.
Lines.
But with it being symmetrical, it is bell-shaped, but it's different than the normal curve.
Yeah.
It's like
Well, it doesn't have to be different. It just the area between your 2 points has to be, what is it? More area outside than inside. So 49% of your data can be between the 2 points.
right.
And the 51% needs to be in the tails.
Right. And so, hold on. It makes it so you can be more confident when you're saying things. Like you're saying, I'm more confident that my data lie underneath or like in our range. I mean, hold on. You're less confident that your data is underneath your bell because you don't know the standard distribution.
Yeah, you don't have your standard deviation.
Right.
You're
That's what it is, the standard deviation. Okay.
figuring it out without it. 2, the degrees of freedom, that equals your sample size minus 1.
Right. And I mean, I think I'm not really sure how that plays into like how do you calculate that into something? Do you use like the Excel program that they have?
That's what they said in the reading. They said like we're not going to give you the stuff to calculate it. You're just going to plug it in. So
cool.
The quantitative whatever.
Yeah.
You get a zip file with 3 Excel documents.
Right.
The last one that's called quantitative. I don't care. It's called quantitative inference.
Yeah, I have that up right now.
So you have like variable 1, summary statistic, confidence level.
Right.
So I put all the numbers in. There's 19 of them,
cool.
or 14 of them.
Down from in the part 2?
Yeah.
Cool. Okay, so then question number 3 is, what is the formula for the 1 sample T confidence? What does the 1 sample mean?
No.
What is saying like the T confidence interval? I get that.
Confidence interval for you when standard deviation is unknown. I don't know for the 1 sample. So
because like the formula is the same as calculating for Z.
Yeah.
It's like the X minus, but it's T, and then instead of a standard deviation, we just have an S value that we get from.
I think they give it to us.
Okay.
I don't know where that. I don't know. I didn't see anything in the reading that gives you S.
Right.
I mean, I could try and look in it again. Well, this is just great. There's 1,000 S's on this page. Oh, there's just too many. But they're highlighted now, so I can see standalone S that's maybe in bold. I mean, but you're already hitting formulas that use S, and they don't.
They don't say how to calculate it, but
they don't explain it anywhere.
Yeah. Okay. So it's one of those things that the program will just give you.
Hope so. If not, we'll figure it out.
Okay. Sorry, brother Wilcox, but the Dodgers are playing and they're up 9-0 now. Just letting Andrew know. They just scored 2 more.
Well, he shouldn't care because we're from LA, so it's not like it's some random team.
Right. Okay.
Danielle said she's ready. You might want to send like an invite.
Yeah, I'll resend it.
Yeah, you should ask her if she thinks it's at 7:30 because last time she was ready.
She tries to call at 8:30.
What's that? Yeah. And it was Forsyth, which is a surprise. I don't trust him.
Just as far as you can throw him. And,
Okay.
while she's like getting in, I gotta grab a charger for my phone.
Okay.
It's gonna die.
Babe, do you see my thing I sent you? Power Rangers. What are you talking?
I do Ninja Turtles.
No, definitely not.
Why? You could be
I'm not
April.
dressing up as a- No,
Why not?
because that's weird.
Why is that weird?
Because she's like,
Megan Fox.
no, she's not me.
Hi.
Megan Fox.
Hey.
Hi. I'm sorry.
You're okay. Nailed it.
You got turtle shoes.
I know.
And I would just be some side chick.
That's not how it works. Have you ever seen Ninja Turtles?
Yes,
I don't think you have.
I have. It was on when I was a child.
There's that light in the way.
There we go. So we just barely started with part 1. Did you get a chance to do the prep, Daniela?
Yeah. Almost. Oh.
Good.
Almost all that. Sweet. Maybe you can help us. Where do you find the S? So for like the formula, x plus or minus t times s over square root of n, where do you find the s?
Where?
How do you get
Yeah.
how do you calculate the S?
With the thing, like the Excel thing.
Oh, you just plug it in the Excel file.
But I
Cool.
don't see where it pops up.
It's on the variable 2. No, sorry.
It's the standard deviation of the
Yeah.
sample.
That's just it. Standard deviation.
And my thinking is that it's because you're not comparing a sample to a population. You're just doing your sample.
Yeah.
So like you don't have a parent standard deviation. You just are doing this standard deviation. And so the odds that this represents everything, you have to be a little bit more
You're a lot
less.
less
You have to
confident.
be a little bit less confident in saying that.
Okay.
Cool. Okay, so we're on question 4.
Yeah, 4.
Yeah. So do you want to do question 4, Daniela, for
Yeah.
part 1?
What are at least two differences between the one sample T confidence interval and the one sample C confidence interval we covered in lesson 10? So I answered that we use the sample standard deviation instead the population standard deviation. This is one, right? And
Yeah.
the other one is use the C-score instead to use the C-score, we need to use the T-score.
Right.
Yep.
Yeah.
Cool.
Awesome.
Yeah.
5. When conducting a hypothesis test for a single mean with sigma unknown, what is formula used to compute the test statistic? Normal distribution for x, and then a simple random sample.
Well, this is asking for the.
No, that's 5. 5.
This is asking
5
for the
is-
formula, right?
Yeah, it's t equals x over the mean divided by s divided by the square root of n.
Right. The same way we found the Z.
Mm-hmm.
Cool. Okay.
And then 6 is the requirements. Those are the 2 I just said.
Right. Okay, we'll get on part 2 then. And Daniela, Andrew said that he already put the numbers in.
What?
So the numbers for part 2, like the 27, 35, 38, Andrew already put those in. So we'll just use his numbers.
What are the requirements? The mean and all these things?
So read part 2, or I'll read it. So a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients who purchased an investment property. Their ages are 27, 35, 38, and so on. So Andrew plugged those numbers, those ages into the Excel thing.
Uh-huh.
And so we're just going to use his numbers.
Oh, you need to use this formula. Okay.
I think we will have to use it.
Oh, can you see or not? It's this one. Or I don't know. Here, aquí.
Yeah.
So, I put the numbers in the Excel thing, and then the sample mean is 46.73.
Mm-hmm.
And then this first minus the standard deviation. No. Minus the t-score, that is 2.1448. And then I multiply that for the standard deviation, that is 8.83 divided by the
Square root?
Yeah, of 15.
Uh-huh.
And yeah, that's it.
Okay. And you should get 41.845 and 51.622.
I get 41.8. And 51.6.
Perfect.
Yep.
Yeah.
Mm-hmm. Yeah. So that was 8. So with 9, now we plug in 99% confidence level.
So we need to change only the t-score, right?
Right.
Yeah.
But
So you see where it says confidence level?
Uh-huh.
I think you just need to change that to 99, and the formula should fix. I didn't see it change though. Okay, there we go. Confidence interval is the thing that changes.
Right. Right, because the confidence interval is what you're basing it off of.
Uh-huh. So Daniela did it the long way with all the math, and I'm just looking at the formula now for the second one. And it's 39.948 and 53.518.
1 second.
And that lines up with the answer key.
Mm-hmm.
Do you see that, Daniela?
The answer key?
Yeah, so one sample t-test, you see where that box is on the Excel sheet?
Mm-hmm.
And then just the bottom right, the confidence interval.
Yeah.
So you put the numbers in the formula, which is awesome. And that's how you work it out. But if you can use the sheet, you just put the numbers in and then it tells you.
Hey, I'm gonna do it real fast, Andrew. Do you want to just tell me the number so I have it over here too?
On your Excel thing? Yeah, you see that?
Yeah.
It's a shortcut.
Yeah.
All right, Eric, your numbers are 27,
27,
35,
35,
38,
38,
49,
49,
55,
55,
58,
58,
56,
56,
50,
50,
51,
51,
45,
45,
46,
46,
56,
56,
49,
49,
48,
48,
and 38.
and 38. Okay, and then
and you just change the confidence level. I mean, that right now, the confidence interval in the bottom right, that's what question 8 was telling us.
Right, but now if
question
you
9, you just switch that to 99.
So,
right, so now the confidence interval is 39.9 and 53.5.
Mm-hmm.
So Did you have to compute the mean by yourself?
No.
No, you
the
put it
mean
in
is-
and it gives it to you.
Uh-huh.
Hmm.
But it is not in the first cuadro. It's in the second
Oh,
one.
I see it now.
Oh, so it says now using your class software, compute the following two, and that's for 10. So it's the same answers as 8 and 9. So we should do it the way Daniela did it
Right.
for 8 anyway. Okay, so X our X value, what are we using for our X value?
For X, 46.73.
Isn't that what we're using for the mean?
Yeah.
Yeah. So we.
Okay, so X plus or minus T. So okay, I got you. It's 46.733 plus or minus T, 16.117
Uh-huh.
times S, 8.827.
What was your T score?
T score was it 16.117?
No, it's 2.1448. I think
What?
it's where it says standard error of the mean, I think.
Okay, mine says 2.279.
0.2.
Do I have to change it? Because
I don't know.
there's a formula in it.
Mm-hmm.
That's weird.
I don't know why.
All the other numbers line up. That's the only one that doesn't.
Right.
Oh, because I'm still on 99. No, it doesn't change it even if I go to 95.
I don't know. Maybe I am wrong.
Okay, it needs to go out.
The numbers are.
So the formula was the box for n divided by the square root. Or wait, hold on. Standard deviation divided by the square root. Yeah, that's what it should be. It should be 2.279.
Maybe, yeah.
That's weird.
I am checking my numbers again.
Your standard deviation is 8.827, right?
8.83.
Okay, yeah. Well, let me see if that's okay. Yeah, I'm not gonna mess with it because maybe I'm missing a number. 27, 35, 38, 49, 55, 58, 56, 50, 51, 45, 46, 56, 49, 48, 38. No, I got all the numbers. I don't know why my standard deviation is different.
Mine.
Or my standard error of mean.
Your T-score.
My T-score is different?
Right, because the standard everybody has 8.83 as our standard deviation, but my T-score is also 16.1.
Mine's 16.117.
Yeah.
I'm doing again. Give me a minute.
Let me just run these numbers and see what. So the standard error of mean is your standard deviation divided by your n value, the square root of your n value.
Right.
So it just gives that to you. So you don't have to. I mean, I can see where the numbers are working here on the computer.
No,
and what they should
I wrote again, and my T-score is 2. No, my standard error of the mean is 2.279.
Okay, cool.
So I don't know why I have other number.
Okay.
Yeah, I'm sorry.
Probably.
So the T-score is 16.112 or 117.
Yeah.
Okay.
All right. So I got the formula written down. My phone is my calculator, so I can't actually. I mean, I guess I could pull it up online and do it. Let me get an online atlas or whatever it's called. Desmos.
So what do we use for our x bar to find the t?
So you're just going to use the mean.
So does that mean it's going to be?
So
it's not gonna
I don't think that other formula where you're talking about t equals x.
Yeah.
Yeah, I don't think we can do that. I don't think they give us the numbers to do that
Oh,
because or your mean is 0.
right. And I guess that's what it was. I guess that's what it was saying in question 1.
Uh-huh. 6.733. All right, I'm running it right now. 16.117 times 8.827 divided by square root of 15. Okay, I got 83.4633. That seems too high.
Hold on.
Mm-hmm.
So you did
Yeah, it's way too high.
t-score, which is 16.117 times the standard deviation. Well, maybe we have to do it like this: 8.827 divided by the square root of 15
Yeah.
times 16.117. And mine says 30.
Plus
Mine says
46.733.
plus the mean.
So 46.733 plus, yeah, because you're going x bar plus or minus t times s over square root of n, right?
Oh, right.
Yeah, so mine's coming up weird.
So I get another number with
Okay.
that answer.
What do you get?
The first one is 41.534.
And that's close to what you should have.
Yeah.
So what did you use for your numbers? Yeah.
Nah, I changed for 2. Well, no, it's the sample mean is 46.73. This
Okay.
minus the t-squared, and I changed the t-squared, that is 2.279, right?
Okay.
And then I use the standard deviation divided by the square thing, the 15.
So she's using the standard error for her t.
Mm-hmm.
Yeah.
Instead of the standard deviation.
Instead of the t-score. Instead of the t down there on the second box.
No, she's using the regular t. I think she's, instead of s, where we're putting in standard deviation, she's doing standard error of mean, right?
So no, we need to use the t. I don't know the
But
t thing.
when we use the
16?
t, it comes out bad.
Okay,
Let's try.
2.2. I'm gonna try 2.279 in mine.
Yeah.
So instead of the standard deviation, 2.279, 56.217. Is that the tall one, the upper limit?
Sorry. 51.621 is the upper limit.
Okay. Well, I got 56, so that's not right.
And I got 37 when I did the lower limit, and that's not right.
Son of a gun.
I don't know why.
But she totally got it right the first time.
Yeah.
I don't know what happened because I erased everything of the Excel thing.
So
But I wrote those. I don't know why.
Okay, 1 second. Let me do what she did. Times 2.279. Wait a second. 8.27 divided by square root of 15 times
2.
I don't know.
Yeah. Well, so I put in, instead of the t, that we
Yeah.
were using the t-score, I used that standard error of mean, and I got 51.927.
So you went 8.827 divided
8.827
by the square root of 15.
times 2.279 plus 46.733.
279. Oh yeah, and then 46 minus that. So that 46.7 plus.
Okay, and I'm at 51
Yeah.
points. 51 points. I'm close, but I'm not there.
Are you using all the decimals?
Yeah. I mean, I can take them out and see what happens.
Mm,
50, and so I did only 2 decimal places, and it's 51.93 as my answer.
Yeah. So for whatever reason, it's that the standard error of the mean is what it's supposed to be used for the t-score.
I think so, but the numbers still aren't coming out right. And if we can't get the numbers to come out right, then on the tests or quizzes or whatever, we're not going to get the answers right.
Yeah, we're just gonna have to use this thing.
Yeah. Okay. I'm okay with that.
Yeah.
I mean, it's annoying, but it is
Right.
what it is.
Right. Wait. What if you used n-1 for under the square root?
You square root of 14.
15, right?
Yeah,
One
n minus
second.
1 is only the sample size.
So then
I mean,
46.733.
you could try it.
It goes down farther.
Yeah. I think the only time you're doing n minus 1 is when you're talking about degrees of freedom.
Right.
Because like look at the chart. Your n is 15 and your degrees of freedom is 14.000.
Right.
Anyway,
Where's that coming from? Where's
Dave.
the extra like 0.3 coming from?
I don't know. I
how's the
think
mar-
two are. Give me a minute. -1.
how does the margin of error for 95 compare to? I don't know. They're not that different.
Well, to answer the questions from what we have, let's do. So what question are we on? Question 10? No, 11.
We did 10 already. We're on 11.
Yeah. So how does the margin of error compare?
So it's a smaller margin, or the margin of error for the confidence interval is smaller for 95% confidence than
Right.
99% confidence. This makes sense.
Right.
You're less confident because your numbers are narrower.
Right.
You don't have as many numbers you can work with.
Uh-huh. So rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average of age 47. Use the 0.05 as your level of significance, so we're going to use 95%. Follow the following sequence of steps, fill in your answers at each step, and show all your work.
So the null hypothesis is they're 47 years old.
Right.
The alternative hypothesis is that it doesn't equal 47.
That they're not 47, right. Okay.
Compute the test statistic. First compute in the formula showing your work below, then check the test statistic by inputting the data in the software. Okay. State the degree of freedom, 14.
Well, what's the test statistic from what we have?
It's the numbers we plugged in, they're the same numbers.
Okay. So is it the mean? of those numbers?
Yeah, I mean, that's probably the test statistic. I don't know what the answer key say.
We're gonna use the same numbers that we used in the last one.
I think so.
So B, the answer for B is T equals negative 0.117, which is 47. If I'm looking at it right, that's 47 minus the mean.
Right.
No, it's not. Where are they getting that number?
Yeah, I don't know.
T equals negative 0.117.
Ah,
Oh, but
I get. You need to change in the Excel thing, and you need to write the null hypothesis and the type of test.
Right. So the null hypothesis is 47.
And then
not equal to.
Fixes everything.
Danielle nailed it.
And then greater than is supposed to be what? Not equal to?
not equal
And
to.
then null hypothesis is 0.
The null hypothesis is
47.
no 47.
47.
Daniela, you're a genius.
Oh, crushed it. And that makes that. Well, our other numbers were okay from the one before.
Okay, 8.827 times. Well, hold on.
Because those didn't change. Those didn't change any of the variable one box with n, mean, standard deviation, and standard error of the mean. They only changed the one sample t-test.
Mm-hmm.
And it has that box, null hypothesis, so we need to make sure that's right every time.
So maybe we need to use the t thing like minus 0.7. Okay.
Yeah, negative 0.117 times 8.827 divided by the square root of 15. That gives a crazy number. So. So based off of that, though, we're not getting the confidence intervals.
No. Mm-hmm.
We were getting them before. So maybe it's still 8.827.
What are you talking about? My confidence intervals are good.
Well, on the sheet, but when I do them on my calculator.
I've just given up on that.
Thank you. Well, I trust the Excel sheet, so.
Because they match up with the answer key, so.
Right.
But if they got their answers off of the Excel sheet and put it in there and they didn't actually do it by hand, who knows? Maybe something's messed up.
Right.
All right, we're supposed to plug this into the applet.
Plug the to find the p-value. Yeah.
Yeah, you sketch the t-distribution and shade the area which represents the p-value. So I'm assuming the p-value is 0.9085, so that's what we're putting in as the area.
Right, but round it to 3.
90.
So 9.909.
Yeah, so that gives you the z-score of negative 1.69 and 1.6.
Well, we have the z-score. We just call it a t-score. And that's negative 0.117.
But that doesn't match up with this then.
That should give you 0.909.
The z-score?
Or it's because you're using the z or the normal probability applet. You have to use the student's t probabilities.
Oh, where's that?
Oh, maybe in the book was like a graphic, but instead to say the z-score, tells the t-score.
Right.
So maybe we use That
Yeah,
one?
I'm gonna go
Maybe
to that
we're
right. I'm gonna go to that right now.
The T distribution applet at normal degrees of freedom, x equals 47. No, 46 point what? 0.773 or 733.
For what? For our X?
Yeah.
Yeah,
T is
yeah.
T x is greater than x. I'm not sure what that means, and I don't know what this red one is. Maybe that gives you the top and bottom. That's what we're putting in. So we'll put in 51.622. Oh, it must be between 1 and 0. The heck? So what number do I put in? Do you guys have the applet open?
I actually haven't found it yet.
If you just search T distribution applet BYUI,
Okay.
it comes up. The student's T distribution.
I no problem.
I don't know what this means though. Ooh, I think I might have figured it out. I don't know why that number is like that. Okay. So my student's T probability thing looks a lot. Oh, I think I'm on T
Let's go to some
distribution. Okay,
Iowa
student's T probability. The heck? No, I'm not getting it to be that right one.
Yeah, I keep finding the one from Iowa State.
Oh, I'm getting this thing that's from BYUI, but like it's not the right thing. It doesn't match the picture.
Right.
Mm-hmm.
Maybe there's a link to it in the textbook.
No, I tried to use the applet thing about the T score, but I can't.
Yeah. I'm not finding it either.
Well, this is crap because we need that.
Yeah, how are you supposed to know the percentage or like the probability?
The degrees of we are in letter C, right? Of 12.
Question 12.
So
Yeah.
degrees of freedom is 14. I think
Right.
I think we're on D. At least that's the one I'm working on right now.
Maybe I will choose the
See if I can
value.
page not found. Texas A&M.
What the junk?
Oh, hold on. Okay. So if you go to the normal probability applet,
Huh?
well, it's not exactly, but it's close. If you put in 0.9085 in the area, but you have the tails shaded, which is what you need to shade if you look at the graph
Right.
on the answer key, the z-score
Right.
comes out negative 0.115 and 0.115. So
So
it's a lot closer, and I would imagine because it's the normal probability applet, not the t distribution one,
right.
that it comes up like that. The t dis.
So if let me see if I find out what you're saying. So you shade the ends and you go negative 0.117.
So no, so you put in the area, and it's supposed to give you the z-score.
I think, but we know the t-score.
Yeah, we also know the area, the p-value,
How do we know the p-value?
because the Excel sheet gives it to us.
Oh, I see. It says
The p-value is also in the Excel thing, right?
Uh-huh.
Yeah,
So
because
maybe
909.
It's the right p-value, because if 9.909, oh, and I did, so I'm just going to use the normal probability applet again and see what happens if I do
But
0.9.
0.909 gives you the t-score of 0.114.
It goes the other way.
Right.
Well, there's something between because this image that they give us, this screenshot from the thing, says student's t probability, but that doesn't exist.
That's what I was looking at. And then I say we move on.
I mean, I'm cruising through the homework. I'm not seeing it anywhere.
I can find you. I can use the t-value, the t thing, and like the t-applet. I can use it. I don't know.
Where did you find the t-applet?
In the book, and
Oh.
there is a part that says, before to. I don't know how to explain it. So
What step is it under?
And it's in the second. Is it 1, 2, 3, 4, 5? The sixth paragraph. In the sixth paragraph, click here to explore how the shape of the tree distribution changes.
Oh, I see. I found it.
Oh.
Okay.
So then if you put in 117, you get, degrees of freedom we need to change.
They're still different, though.
No, if you change the degrees of freedom.
Yeah, I changed it. 14 degrees of freedom, area 0.909, and my t-score is 0.116.
Yeah, because you got to put in the t-score first.
So the area is 0.43.
Okay, and then 9085. Okay,
Yeah.
cool.
So
all right, cool.
The area is 0.9085.
Yeah, and that's what it is on the Excel sheet.
Right.
Okay.
Okay, bueno. All right.
State your decision.
Entonces, let's do the quiz.
Do you reject it?
Oh yeah, you do reject it because it's way higher than 0.05. The only way that you reject it is if you have the probability less than 0.05.
Mm-hmm. Yeah.
Oh, wait. It says display. Okay. Okay. Let's get started on the quiz.
Yeah. Burning daylight.
Get rid of you, normal probability applet. Don't need you anymore.
Yeah, just okay.
Upgraded.
Daniela, what are number 1 and 2?
What are number?
Yeah, on the
¿Cómo?
quiz. Did you open the quiz?
Yeah. So yes and yes, right?
Ah.
Always.
Hey, there's the T distribution applet right there.
Son of a.
Okay. Question 3. In previous lessons, we had assumed the population standard deviation was known. In this lesson, we are making different assumptions about the standard deviation. What has changed? We assume the standard deviation is unknown.
Yeah, the standard deviation is unknown.
Yeah,
We're not assuming it. We don't know it.
right. And so we have to find our new standard deviation.
We have to
Okay.
find our T.
Let the null hypothesis be that the mean equals 8, and the alternative hypothesis is that the mean is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size of n equals 9 and computes x, the mean is 11, and that s equals 6.
Is the standard deviation known? No, it's
So
not
because
known.
s is 6.
Yeah. Assume that the population standard deviation. Oh, yeah. I'm sorry. No.
That's okay.
Nice.
And then what is
It
the
literally
value of
says
t?
it's not known. Come on. They're too easy.
Crazy girl.
Yeah.
Confusing
Okay,
them.
then the t value is going to be the x bar minus the other mean all over s over 3.
It's 11 minus 8.
So is that 3 over 6 over 2?
Okay, 3 over s divided by square root of n. So that's 3, and s is 6. So yeah,
3 over 2, and it says round to 1 decimal point.
3 halves. Let's
So, we need to use the formula that is t equals the sample mean minus the population mean.
Right.
So, what is the population mean?
The population mean is 8.
8.
Oh, jeez. Look at all those things. Copy and paste them into the software. Yeah, right. It doesn't let me copy and paste them. Are you kidding me? All right, Andrew, you want to read those numbers to me?
yeah.
1 second. Let me delete these other ones.
You can just
1.5.
Yes. Okay, I am ready.
98,
98,
99.6,
99.6,
97.8,
97.8,
97.6,
97.6,
98.7,
98.7,
98.4,
98.4,
98.9,
98.9,
97.1,
97.1,
99.2,
99.2,
97.4,
97.4,
99.1,
99.1,
96.9,
96.9,
98.8,
98.8,
99.9,
99.9,
96.8,
96.8,
97,
97,
98.7,
98.7.
97.6,
97.6.
98.7,
98.7.
and 98.2.
98.2. Okay, and how many N's were there?
Too far. It should tell
There-
you, shouldn't it?
Oh,
One,
5.
2, 3, 4, 5, 6, 7.
Looks like-
Yeah, in your Excel sheet, it should tell you your N,
Oh, yeah, okay. I see it. It says 20.
but your mean.
Okay.
What's your mean?
Let me get rid of
Round
the.
Round to 3.
I got to get rid of the things that I put in there. Okay, so the mean is 98.220.
98.
Yeah. Hold on. What's the confidence level?
That shouldn't
And-
matter for the mean.
Okay, what's the null hypothesis?
The null hypothesis is that it's
98.6.
98.6.
90 what?
98.6.
98.6. Okay.
And
Cool.
The alternative, Daniela?
it's less than 98.6.
Mm-hmm.
Okay.
What is the S?
So the S being the standard deviation.
Maybe?
Yes. And that's 0.922.
That's rounded to 3.
Well, let me check real fast. What did I say the question 6 was?
You said at 98.220.
Okay. And then I'll check again what the S is. Yeah, so the standard deviation is 0.922.
Okay. And what's the T-score?
0.922. And then the T-score is negative 1.843.
And the p-value, rounded to 3.
So we need to use the applet, right?
So so this gives us the p-value as well, the Excel sheet.
Ah, yeah.
So I'll read you the whole thing. I don't know what we should use, but the p-value is 0.0404881.
0404. So it's
81.
0.
So do you round the 04 or the 04? No,
It's
because
0.040.
It's 0.040, yeah.
yeah, that's I think what it's supposed to be.
What's the correct decision based on the evidence? It's good. Because 04 is less than 05.
Right. And well, are we 95% confidence?
I think so.
Does it say? Yeah, because it says significance is 0.05.
Yeah. So we accept it.
So we reject the null
Yeah,
hypothesis.
we reject. Yeah, reject.
Yeah.
Awesome. You dummy thingy. We can't copy you in this test format.
All right, I'll do these ones. You read them to me.
Okay.
I'm ready.
59,
59,
14,
14,
37,
37,
62,
62,
68,
68,
2,
2,
15,
15,
9,
9,
157,
157,
27,
27,
37,
37,
2,
2,
55,
55,
86,
86,
14,
14,
4,
4,
40,
40,
36,
36,
47,
47,
9,
9,
and 61.
61. Okay. Why would they use 21 numbers?
They're a bunch of chumps. 1, 2, 3, 4, 5, 6,
Okay.
7, 8, 9, 10,
So-
11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Or we have a confidence level of 99, the null hypothesis is 40, and then
Not equal.
not equal to. Okay.
What's our p-value?
Our p-value is 0.995270372. So 0.995.
Okay.
0.995.
What decision do you make?
We failed to
Well,
reject.
the t-score is 0.006, so you reject
Failed
the
to
null
reject.
hypothesis.
It's failed to reject the null hypothesis, right?
No, you reject it. Because
No,
the-
because the t-score
No.
doesn't tell us that. It has to come from the p-value.
Oh, yeah, but the sigma in this case is 0.01, right?
Right. So Andrew, last time in question 9, we rejected the null hypothesis because the p-value was 0.040.
Uh-huh.
So if you said that the p-value is 0.995, then it's not less than the significance.
Okay.
Is the way I understood
Yeah, I think that's right.
the reject.
hmm
Okay.
Fa-
This time, the alternative is less than.
Yeah. So just change that on the Excel sheet.
Yeah. So the p-value now is 0.50236, and
So
it's still you fail to reject it.
did the p-value decrease? Yes.
Yeah, but not enough.
But we still fail to reject, right? Now do 95% confidence interval.
Okay. So the p-value stayed the same. The confidence interval just changed.
Right.
What's the lower limit of this? The lower limit is 23.499. So 23.5.
23.5. Okay.
And the upper limit is 56.6.
56.6. Okay. Well, that's everything.
And submit.
All right, you submit it, Andrew. Let us know.
Wait a minute. What is the lower?
The lower limit is 23.5.
We got them all.
Jeez, that was the craziest one we've done.
Yeah, it's a long one.
Okay, did you get 16? Daniela?
I didn't escape. I am lost.
Oh,
So-
sorry. So what's your last question you have?
So I am in 13 right now.
Okay.
So we say that decrease or increase?
It's decreased.
Decrease.
Yeah, the p-value was cut in half.
And so in 14, what decision do you make? Reject?
Yeah, you failed to reject.
How to reject? So, okay, give me a minute. I'm going to save it.
And you got 15 and 16?
Yeah. Save.
Awesome.
Good job, team.
I obtained. Give me a minute. 94.12.
Oh,
Which one's
what did you get different?
No, I don't know why. Okay.
Okay, so let's go from the beginning, and I'll give you the answers again.
Okay. So the first one is yes.
Yeah,
The
well,
second-
actually, which one did you get wrong? Because it shows you.
3.
You got number 3 wrong. So
Right?
number 3 should be, we assume that the standard
Female.
deviation is unknown.
Right. But I don't
You got
know
that-
why.
You got that wrong?
But no, it's because I don't know why I put we assume that sigma is the same that the mean.
Oh yeah, I don't know why you put that either.
Yeah, I'm sorry. Question 4 is no. Question 5, 1.5.
Uh-huh.
Right?
Yeah.
The other one is what is the mean? The mean is 98.220.
Yep.
Next is 9.922.
Uh-huh.
Then is minus 1.843.
Yep.
The next one is 0.040. 1.40.
Correct.
Then is reject the null hypothesis, right?
Yes.
Then is 0.995.
Uh-huh.
Fail to reject.
Right.
Then decrease.
Yes.
Fail to reject.
Uh-huh.
23.5
Uh-huh.
is 56.6.
Yeah. So just that one you got wrong.
Yeah,
So
the other one is that.
if you want, so you should just open up the quiz in another window. Just reopen it.
Yeah,
Okay. Awesome.
yeah. Thank you.
Uh-huh. Okay. Well, I
Okay.
think we'll see you guys on Tuesday. All
Yeah,
right.
thank you.
Adios.
Bye.